Go.
Good evening, members of the SMAC. We are the SHARK. We're the Seismic Hazard Association for Response to Quakes. And my name is Sean, this is Dar and Rachel, and we're here to represent our team today. So we're here to talk to you about the possibility of a Seattle earthquake and the effects it would have. So first I would like you guys to all close your eyes and walk through this scenario with me as I narrate it. It's 8:16 on a chilly morning, early in the spring. You've just arrived at work, and you're pouring your first cup of morning coffee. When you become aware of a noise, within seconds, the rumbling becomes a roar, the floor beneath you heaves, and the building begins to pitch and shake, violently throwing you to the floor. The Cascadia mega earthquake has just triggered a 9.0 magnitude earthquake. The roaring is joined by a cacophony of crashing windows as they shatter to the ground, and every unsecured object in the room, from the desk chair to the pot of coffee, goes flying to the floor. Shaken loose by the shuddering and jolting of the building, the ceiling and particles drift down like snow. Then the lights flash. Remembering to drop, cover, and hold, you crawl under the desk, hold on tight, and tell yourself that it's going to be over in just a few more seconds.
Probably it will.
But it goes on and on. Finally, after the shocks appear to have subsided, you get back on your feet and you run to the nearest exit. But you find out the stairs are unused and you're trapped. Finally, after several hours of waiting, you hear the rescue team in the stairway calling out for survivors. Just as you're about to call out for help, the worst case scenario happened. The Cascadia subduction zone has actually just triggered a second earthquake from the Seattle fault lines. And this additional 7.2 earthquake was enough to knock down the old building similar to the one you're in, trapping both you and much of the rescue force in the city. This is it. This is the big earthquake we've been all waiting for. So now that I've walked you through, we're going to take you through a simulation of what would actually happen when an earthquake right here in Seattle. And right here to your right, this is the Alaskan Viaduct, a major highway that runs right through the city. When the earthquake hits, the ground shakes, the structures around will shake, causing traffic to come to a complete stop, often causing accidents and crashes along the way. And right now we're going to focus on the overpass and the seawall. As the roads crack, the soil fills with pressure and becomes liquefied. And under the pressure of the liquefied soil, it's going to press against the seawall, causing it to fail and eventually collapse. As you'll see here in just a second. And with it, it'll take along with it much of the waterfront property. And as the soil is rushed out, much of the utility pipes underground will be damaged as well. As you can see, the overpass is not designed or built for this magnitude of an earthquake. And this is due to two main reasons. The first are the columns. They're old and they're weak. They're not meant to withstand such magnitude. And the soil liquefaction will actually cause the ground to give way and for the foundation simply just to collapse down. And with this, it'll take out the power grids, causing a blackout. With the numerous aftershocks that's going to follow, you're going to see the damage continue on. As you can see, additional segments of the overpass is going to collapse as well. With it, continue to rush out into the ocean as the ocean rushes in, trapping many of the vehicles and the individuals with it. But more importantly, the natural gas pipelines, both underground and within buildings, to catch on fire, combust, as you remember in 1906, the Great Fire of San Francisco, a situation similar to that. As you can see, this is not limited to the waterfront. This is a situation that will happen throughout the city wherever soil liquefaction is an issue.
By the way, the smack meets right in that building on the Alaska Way.
But let's not forget the buildings. They're important too. Much of Seattle is built on brick buildings, and these brick buildings are more than likely to go down because they're simply not meant to withstand this sort of an earthquake. As for old buildings like the one I explained in the scenario, while they may not collapse, but they will be damaged beyond use such that after the earthquake, we'll have to tear it down and rebuild from there. So now that I've shown you what an earthquake the devastation effects, I'd like to point you to the map that maps out within Seattle that is at risk. As you can see right here, the increase in redness indicates the dangerousness of soil liquefaction and earthquake shakes. And right here, this is where much of Seattle's financial district is located. Now imagine the devastation as those buildings come crumbling down under the soil liquefaction. Let's not forget, University of Washington here is actually a very dangerous location because it is also sitting on top of the liquefaction zone. So let's not forget your financial district and some of the finest minds in education and in research. That's going to bring your revenue that we got to watch out for. So, probability. This is the probability you're going to hear today, and it's important, so I need you guys to stay with me here. So these red bars here, these indicate where major earthquakes has happened within the past 10,000 years. And they're all 8.0 or larger magnitude earthquakes. The black arrow, which we've zoomed in right here, this is where we are today, 2015. 2015 to the first red bar to our left, that is a time span of 300 years. And this is a whole 3 hours of every one of these earthquakes happened within this 300 years. So what does that really mean for us here in Seattle? That means that an earthquake will happen, and it's going to happen. We must prepare for it because the clock is ticking. So we've broken it all down for you here. We've taken the probability of an earthquake, and we've taken the impact, summarized it here in a pie chart. As you can see, earthquake takes a large amount of the risk that we must be preparing for as compared to floods, wildfire, and we must act now in order to prevent the devastation.
All right, so in this picture on the right here, I divided into 7 different districts. 5 of these districts are located in areas with extremely high seismic hazard, and they are a priority to evacuate, especially right here, there, and right there. So, when the 9.0 earthquake hits Seattle, the evacuation plan will be completely on what bridges are in use, since Seattle is very reliant on it. Those main bridges, which is located around there, Fremont, University, West Seattle, 520, and I-90. I-5, University, and West Seattle are located in areas of dangerous seismic hazards, while 520 and I-90 are floating bridges. They're not located in areas with high seismic activity after an earthquake. 520 and I-90 should be able to withstand an earthquake. However, if a siege, which is a surface tsunami wave, forms, then the bridges could fail. 1, due to enough pressure buildup that it would cause the bridges to bend. Or 2, anchor breakage due to an underwater landslide, for example. The bridge is more dependable than the I-90 bridge because it is a straight shot, whereas I-90 goes to Mercer Island and then over to Bellevue. Therefore, if the 4 bridges on the main part of Seattle that are all in hazard area and I-90 were all unusable, this is the evacuation plan that I propose. Lake Union, which is located right here, and the canal that divides the city is the north-south divider. I-5, which you can runs straight through, and that is the west-east divider. So, I propose that we evacuate the entire District 7, so the region of Magnolia, which is right here, and Queen Anne, which is right there, and that is the primary region that needs to be evacuated. So I propose that they evacuate the 520 bridge. So over to Bellevue. Alright, so Districts 1 and 2, which are presented here, just zoomed in. District 1 will need to evacuate using Delridge Way, which is on the west side of I-5, and it runs parallel straight down. District 2 divided it, the northern 2/3 will evacuate using I-5 South. The third will evacuate using Martin Luther King Jr. Way, which is well on the east side. This district has the most amount of people, so it is able to have 2 access points to leave the city, 2 main access points. In the middle of these 2 districts, which I presented with the circle in the previous slide, is the area that needs to be evacuated first and foremost. Alright, so the northern part of the city, which includes the University District of District, will evacuate using Roosevelt Way, which is right here, and it's parallel. They'll take it for about 12 miles, at which point they can take up I-5 and continue north. Then the Fremont District of District 6 will evacuate north using I-5 north. So, fire stations and hospitals. The picture to the left displays the 26 fire stations that are present throughout the Seattle city limits. As the photo displays, the fire stations are present interspersed throughout the city, and each of the districts that I presented earlier should have up to about 3 of these fire stations. However, depending on the effects of the earthquake on power lines and on underground gas lines, the fire stations will likely have to take part in fighting fires. The picture on the right, the major hospital locations. In the south half of the city, which again is divided by right here, all of the districts are present in District 3. Seattle's primary ones are located in this district, the most essential being Harborview due to the trauma center. And then there are 3 major hospitals that are located in the north. Swedish Medical, which is up there, University of Washington Hospital, and then also Seattle Children's. However, all of them are located in that will, 1, have extremely high seismic hazards, and 2, of Districts 4 and 6 that I propose we evacuate ASAP. Therefore, it's questionable whether or not those hospitals will even be accessible due to the earthquake. While Seattle has a great deal of fire stations full of paramedics and EMTs that will be able to respond to emergencies after the earthquake, the hospitals where the injured people will need to be are all concentrated in one main area in the southern part of the city, and then in danger zones in the northern. It is essential to construct more hospitals in the northern part of the city, and then also interspersed throughout the south so that more people can have access to medical services. So where are these people going when they leave? Those that exit, which are District 6, have a relief station located in Linwood, Edmonds Community College, which is located in the square up there. Those exiting to the east, which were District 7, early station in Bellevue at Overlake Golf and Country Club. And that's right here. Those evacuating to the southwest are going to North Seattle Park, or SeaTac Park. Those evacuating to the southeast can go to locations. They can, in Renton, they can go to a soccer complex, Fire, or to Renton Stadium, and then anyone else left over can also go over to North SeaTac Park. For those who are unable to leave the city for whatever reason, there will be a relief site located at the Space Needle, and yeah.
So I'm going to cover the recovery steps right after the earthquake. So we are going to begin with the infrastructure. So depending on the severity of the earthquake, it may take up to months to years to recover. First, we need to recover or repair the essential facilities like roads and hospitals as quickly as possible to allow smoother recovery. But the majority of time and resources are going to be spent restoring power and electricity, water supply, and cell phone towers. And we also need to consider recycling disaster debris to minimize the cost. So this graph shows the estimated cost of a magnitude of 9.0 earthquake in Cascadia subduction zone. So this was calculated based on the past earthquake that happened in 2001 called Nisqually, and the estimated cost was $3 billion to repair, but the projected for 9.0 earthquake is $49 billion.
That's all? Really? Oh, really? I mean, I would have thought it would have been hundreds of billions, but.
Oh, sorry. Okay, so these are the mitigation steps that we propose and we recommend. So first, we need to retrofit the critical public facilities such as hospital, fire station, etc. Because most of the fire stations were built in the early 1900s, so they're not up to the earthquake code. And if our essential facilities are damaged after an earthquake, then there will be more deaths and increased in recovery time, and ultimately more cost. So as we have noticed earlier, Seattle is heavily dependent on bridges. If there are any breaks in the street or bridges, then it's going to delay the time to deliver emergency services. So we need to make sure that all the bridges are up to earthquake code. Next, we need to focus on the area around the Gaston Way Viaduct because this area is built on dirt fill, which is soil liquefaction. But this area is because it's located in downtown Seattle and it's the main industrial district. And this road carries up to 110,000 cars per day. And we need to build more hospitals in North Seattle, especially District 4, 5, and 6, because they are more safer than Seattle. Because most of the hospitals in Seattle are located downtown Seattle, and if something bad happens, if the buildings aren't reliable, then we need to be able to locate people to other districts. And last, we need to fit natural gas pipelines with automatic or remote shut-off valves so that we can reduce the fire during the earthquake. Also, we should invest in the wireless emergency alert system, which uses the GPS for sending emergency notifications instead of cell phone towers. We also need to build 6 warehouses near the relief sites full of medical supplies, survival kits, food, water, and power generators that will serve up to 50,000 people. This would prevent troubles caused by transporting the emergency supplies in the midst of chaos. We all know that it's not a matter of if, it's a matter of when. We need to be more proactive and when this happens, will we be prepared?
Thank you.
Thank you.